thank you everyone for joining me in the session. I'm going to talk about building a scalable data science platform with R on HDInsight. And okay, so I'm Debraj Gotakota. I'm a senior data scientist in the data group, Algorithms and Data Sciences. And my email information is here, my first name dot last name at microsoft.com. So please feel free to contact me later on if you have some questions or clarifications to make with respect to the presentation. And the content I'm going to present today is the co-contributors. There are quite a few of them, so I just wanted to list them up front. Okay, so I'd like to mention a couple other things. So first off, there are quite a few related talks. I'm hoping you were able to attend a few of them, but if not, I think the slides and the videos will be available from Channel 9, so you will be able to kind of take a look at them. Now, most of them have already been delivered, so that's why kind of they're in lighter gray font. But the one that I encourage you to attend if you can is the last one, which is the data science the process. It's from 3 to 4. It's quite related to the content that I'm going to present today in terms of how one can look at a data science process and develop an efficient data science process. So I think that might be of benefit to you as well. So primary takeaways that I'd like to deliver are the following. So I'd like to go over R and Microsoft R Server and what are the benefits of Microsoft R Server, and how one can use Microsoft R Server on HDInsight platform to do analytics at scale. And finally, I'd like to take maybe 15 minutes of your time to do some demos to show you how you can spin up HDInsight clusters, how you can do some data science process on HDInsight clusters using some familiar development environments. And last but not the least, we keep developing these contents and publishing in public GitHub repositories, making presentations and tutorials out of this. So I'm going to point you to some of these resources. So at the end, it might be helpful for you to go to these sites and find out more about these tutorials, and that will help you adopt some of this code and data science process for your own workflow. Okay. So I'm going to talk about a few different things. First off, I'm going to start off with R. I'm not sure a long introduction will be needed here because I think many of you are here because you know what R is and what the benefits are. But it's also got some limitations as far as the open source R is concerned. And I'm going to talk about the Microsoft R Server, which is scalable and enterprise class and fills some of the limitations of open source R. And I'm going to talk about the R Server on HDInsight clusters, what the architecture looks like, how you can perform data science on that, and then walk through a demo that we have developed and point you to some technical content. Okay, so first off, I'm going to talk a little bit about R, its benefits and some of its limitations. It's the most popular statistical programming and machine learning language. It's got really good visualization and data reporting tools. It's open source and free, right? So all that is pretty good. It's got a very broad community of users, and right now, if you are a statistician or machine learning practitioner, you're taking some trainings, you'll most likely do some training in R, maybe along with Python or something. And it's got a thriving user group worldwide. One of the best benefits of using R is it's the variety of the libraries and packages it brings to the table for you for many different kinds of business problems and business verticals. So it's really rich, and in some cases, really there are extensive books and a variety of packages that help you do very deep analytics in some business domains. Yeah. So I think if you think about the popularity of R, it's been rapidly gaining over the last many years, and in a couple of different surveys, it's been shown that R is probably the most popular analytical language at this time, or approaching that. So if you compare SAS, R, and Python, R is right now the most popular language amongst analysts. And in unified IEEE spectrum rankings also, over the last few years, it's been getting more popularity in terms of its ranking. I think the last couple of years it has been within the top 10, and as of 2016, it is already within the top 5. So it's moving upwards every year that you see these rankings come out. In terms of common use cases, there are quite a few, like I was mentioning earlier. I just wanted to list a few of them, and in cases where there are some business problems that cut across different verticals, I have highlighted them for your benefit. So for example, forecasting is a very rich set of packages in R that you can use. In addition to that, fraud detection, personalization, etc. And also there is quite a bit of packages and libraries in terms of the healthcare analytics. So right now, R is really diverse in terms of its application in use cases. So, but if you have used R extensively, you will also know that there are some practical limitations in terms of data processing, right? So it is primarily an in-memory processing processing framework, right? So you'd have to load the data as a data frame or a matrix in physical memory of your workstation, and you would have to perform operations on top of that data frame or matrix, right? And however, if you develop a workflow, and those of you who have experience with it, you will observe that it makes several copies of the data. So in terms of memory management, it's not really very efficient that way. And it lacks parallelism. So you're not able to do parallel computation or distributed computation if you're in a cluster context with open source R very easily. There are some packages that are now becoming available that enable you to approach that. But generally those things are true if you are using R, open source R, I should say. So in addition to that, because it's open source, there is not enough community support and lack of guaranteed support, timeliness, and no SLAs and support models. So this is where the Microsoft R server can be of help. So it's got guaranteed support and SLA. It works on data in memory or on disk. I'm going to talk about that quite a bit more in the next few slides. And it brings to the table a wide range of scalable and distributed R functions. On top of all the packages and functions that you already have in R, it gives you a wide range of these functions for larger data sets that can become very helpful. And it works in several different compute contexts as well as data sources. So you can work with the R server on top of Hadoop and Spark clusters, SQL servers, for example, and the data source can range from disk on your local workstation to HDFS to SQL Server and so on. So collectively, all these benefits taken together, I think it gives you peace of mind for the support and SLA point of view, speed and scalability because you can have parallelly executed algorithms, and flexibility because once you write your code, you can port it to many different compute contexts with very limited change in the code that you need to make. And all of this taken together gives you much more efficiency than you would have otherwise. So the R server actually constitutes of a few different components. So Scale-R is the unit that has parallel algorithms for you to do ETL or machine learning and so forth. But in addition to that, it also has a few other components such as distributed R, which is the framework which enables you to parallelize your algorithms. Deploy R, which enables you to publish web services and create APIs, REST APIs, and then Connect R, which provides a connection to different kinds of data sources. Now, all of these are available in a variety of compute contexts, including VMs on the cloud, Hadoop and Spark cluster, data warehouses, RDBMS, desktop servers, and so forth. And one of the real benefits of using the R server is is the tenet or principle of write once and deploy anywhere. And I'm going to show you some code snippets later on which will explain this situation much better. So in principle, you can write your code in one of these. For example, if you have a small piece of data or sample piece of data that you're developing upon and iterating through on your desktop, and you can switch the compute context at the very top of your code, and then the rest of the code you can port to Spark and Hadoop and have the code work exactly the same way in a different compute context. And also you have to change the data source maybe to HDFS or something. So with very limited amount of change, you can really port your code to different kinds of compute contexts and environments. Okay, I'm going to talk about the scalar component a little bit more. So if you're a data scientist and you want to understand a little bit more about how the scalar functions work, I want to give you some information on that. Again, I also want to point you to some references which are mentioned here so you can get a much better in-depth understanding if you would like to do that. But scalar provides the algorithms for parallel and distributed processing. So on a workstation, it enables you to use all the cores. And also the other benefit is that you can use the hard drive for storing and importing data very efficiently and doing computations on that. So on the hard drive, the data is saved as XDF formats or external data frames. So it provides an efficient mechanism of bringing the XDF formats into memory and being able to compute in chunks and so on. In a cluster situation, you're able to use all the nodes and you can use distributed file systems like HDFS, and thereby when you get to a cluster compute situation, you can really greatly enhance your ability to work on large data sets efficiently. Now this explains a little bit more about how the scalar functions work. So scalar utilizes something called PEMA or parallel execution memory algorithms. And I was mentioning a little in the last slide that if you have a big chunk of data, then XDF files, saved in XDF files, then you can read the entire data set chunk by chunk into the memory, send it to the worker nodes for computation, and ultimately the computation that was done on different chunks will be brought together, collected, combined, and the combined result for the entire data set will be presented as the result. So if you create models, for example, if you're involved in machine learning, then this would be of a benefit for you to know that there's quite a few algorithms from the scalar package that are available for you to do parallel computation with algorithms such as linear regression, decision trees, boost and random forest, gradient boosting trees, and so forth. So just to know that in addition to that, the machine learning suite of algorithms, there are quite a few others that enable to you kind of the entire process of data preparation, data wrangling, and all the way to creation of models, evaluating models, and so forth. Also data visualization, there are functions for that also. So taken together, all the scalar functions give you that ability to perform on data at scale and do all of your activities from data wrangling, visualization, model creation, and so on. And if there are functions that are not available in the scalar package that you would like to use from open source R, you're still able to parallelize them using this RX exec component of the scalar, where you can parallelize your open source R functions. So if there are some machine learning algorithms from open source R that you would like to adopt, and you want to train the model doing cross validation or multiple folds, so this would be of benefit that you can distribute on multiple chunks of the data and do cross validation and get your optimized result as a result of the process. So I hope I gave you an appreciation for what is available in scalar in terms of the functions and other extensions that you can do with open source R packages. So the typical uses of open source R would be maybe some of the following. So anytime you want to do some analytics that go beyond simple data summarization, aggregation, and so forth, R can be very helpful because the depth of statistical packages in R is very impressive. And if you have smaller data sets or sample data sets that fit in memory, then there are lots of functions and packages in R that you can work with. Creating sophisticated visualizations, that's also a big benefit. There are very nice packages in R that enable you to do that. Creating reports using packages such as Markdown, NetR, if you have used some of that. And finally, there are a fair number of domains where the number of the packages, the depth of analytical capabilities within R is very extensive. So, for example, forecasting, health informatics are some of the things that I'm aware of the depth of the packages, but there are many others, I'm sure. However, because of some of the limitations I mentioned earlier for open source R, typical uses of R server would be when you're starting to work with very large amounts of data that don't fit in memory, or you can't do the computations in parallel. And building models in that take too long to build in R, right? So because you can't distribute or the model doesn't fit in memory or something like that. And working with clusters and distributed file systems. And finally, developing portable scripts that you can use in many different compute contexts. So if your problem involves some of these, then I think you could consider using the R server and some of its benefits. Just to summarize this part of comparing open source R with the R server and where you might want to use it. So if you have big data, you will benefit from using the Microsoft R server. The speed of analysis is important, then this will shrink analysis time. Enterprise readiness is another benefit. And analytical breadth, although there are over 9,000 packages right now in R, very extensive. Like I was mentioning, the scale R packages can also be of a lot of benefit to you because you are able to parallelize your algorithms and so on. And finally, commercial viability. Okay. So in the next few slides, I'm going to talk a little bit about the R server on HDInsight. So the previous speaker, Maxim, gave you a very good introduction about the HDInsight and how you can work with that and do interactive analysis as a data scientist. So I'm going to talk about that, extend what he was talking about, but more from an R standpoint. So if you're an R user, how can you perform these activities, spin up clusters, and therefore prepare a platform that will enable you to do the end-to-end data science process using such a platform. So in a very simplified manner, the HDInsight clusters consists of a few different layers, right? First is your data layer, and you can choose between a blob storage or a data lake storage. However, it will be attached to your cluster as HDFS file system. Then comes the resource management layer in terms of Spark, Hadoop, and Yarn. And finally is the data processor or functional layer, where you can use different kinds of packages or functions for your computational activities. For example, you can use the scalar functions. If you're on a Spark cluster, Spark has enabled APIs now in R to interact with its various data transformation and machine learning libraries, so you can use that also. So it's very easy to set up, elastic, and it's got SLA that you can take a look at, and it brings to you the benefits of the R server. The scalability. If you're very familiar with R coding, then you can really easily translate your coding skills to a cluster situation like that. And the other very important thing is if you're developing in R, then you virtually don't have to change your development experience. So you can have access to RStudio server that's installed on the clusters, and you can simply navigate to the RStudio server and start developing code, and it'll feel very similar to your desktop environment if you have done RStudio or RTVS, for example. And And you can also have access to notebooks, Jupyter notebooks, which the previous speaker described quite a bit. So the benefit is that with all these IDEs and tools, your development experience of data processing, building models, and interactive visualization of data and iterating through becomes very as a nice experience as a data scientist. And these are some of the things I'm not going to go into much detail, but I just wanted to mention that you can, if you have an Azure subscription and you want to spin one of these clusters, you can easily do that through the GUI interface by trying to add a resource and navigate your way through how you would like to create and configure your cluster. So you can choose from a variety of options of which cluster, the Spark is shown over here. You can choose the operating system depending on your cluster type choice. And you can choose between premium and standard. The premium is the one that you would like to choose if you want to use the Microsoft R server on Spark or Hadoop. I should also mention, and I'll try to show some demo of that later on, that you can also spin lots of clusters like that very easily in parallel using shell scripts. Okay? So if you need to create maybe 20, 30 clusters, you can do all of that within a matter of 10 or I should say 20 or 25 minutes all in parallel. And it's also scalable, so depending on your computational needs, you might want to first prepare a small cluster, do some analysis with a smaller amount of data set or sample data set to explore that. But when you want to scale out your code, you can easily go to this scale cluster tile, which I've circled in yellow, and scale it up and down to the number of desired worker nodes that you would need for your analysis. The architecture looks something like this. So first off, you will have your client with which you want to interact with your cluster. So you can set up SSH login with which you can connect to the edge node. Edge node is where the R server is going to be located along with the worker nodes. And anytime you spin up an HDInsight cluster, you will get two head nodes. One is the primary head node, one will act as a backup head node. And the resource manager is on the head node. So if you serve into the edge node, then any job that you can submit to be processed on all the worker nodes, and the yarn resource manager on the head node is actually going to manage the workflow for you. In terms of connectivity, I was mentioning a little while earlier that you can have access to a variety of them, including RStudio, Jupyter notebooks, and you can have even RStudio or RTools for Visual Studio on your client machine. And you can simply connect to the cluster from using SSH and start developing pretty much right away. And again, if you have worker nodes, the jobs are going to be processed in the worker nodes that are shown here. On the cluster, you can do data processing in a couple different ways. If you have a small amount of data that you would like to interactively explore, and maybe build some models and iterate through a little bit, then maybe the memory on your edge node is going to be sufficient for you to do that on a sample data set. And that might really enhance your efficiency in terms of getting some initial ideas about the model, how you, data exploration and so forth. So you can easily process some of your data on the edge node for initial exploration. But after that, if you want to scale out your code and perform your work on all the worker nodes, you can certainly do that. And most of your code is going to work just the same, except the compute context will have to be set differently. And that is what is shown here on your right-hand side. Okay, now I want to show some example of what I mean by write once and deploy anywhere. Okay, so suppose you have your workstation, or maybe you're working on the edge node of your cluster. You can set your compute context to local parallel, and you can then rest of your code you can have fairly extensive data exploration, summarization, and modeling going on, and model evaluation, etc. The typical things that you would like to do as a data scientist. Now, when you are ready to move your analysis to a cluster, Hadoop cluster, this is what you would have to do. And this is really the amount of code that you would have to change to switch your computation to a cluster situation. So Spark, you can set both Spark and Hadoop compute contexts with a few lines of code that are given here. And then the rest of the code that involve the majority of your work in terms of data processing, summarization, and modeling, they can simply remain the same. And that's how easy it is really to switch compute context around and use our server in different compute contexts. A bit more in terms of the detail here. So you can develop in both MapReduce and Spark compute context in HDInsight clusters. And if you have HDFS as your file systems, then you would need to specify that also. And so in a MapReduce compute context, you will set the compute context like that, the file system, and there you can use that data to start modeling and so on. Okay. Now, if you move to a Spark compute context, in Spark, you don't have to change the file system because it's going to remain HDFS, but you can change the compute context and apply the same modeling and other parts of the code. Okay. So now the next few slides, I'm going to talk about how you would like to create a data science process using our server on HDInsight clusters. First off, I'm going to give a little bit of introduction of what Spark is. I think many of you will already know the Spark infrastructure in general, so I won't take too much time for this. But Spark, as you know, is a fault-tolerant and distributed in-memory processing platform, and it sits on top of in HDInsight's Yarn resource management system, and it brings to you a fair number of APIs in terms of the Spark SQL, Spark streaming, MLlib for doing your machine learning activities, graphics for graph processing, and so forth. So all of these APIs taken together really, as a data scientist, gives you one place to do pretty much all of your activities. Okay. So that's the real convenient part of Spark, other than the scalability aspect of it. Now, it's got multi-language support. Since I'd say the middle of last year, the R bindings are available for you to access the libraries that have been exposed in MLlib and so on. Although I must admit that the R functions that you can use today is not very extensive yet, but I believe that will grow over time. And it's got standard libraries for doing machine learning, statistics, and other things in MLlib and Spark ML libraries. Okay. So like R, it's also got a wide diversity of uses in terms of the different industries and business scenarios. But as I looked into this, I realized that the application scenarios, at least as of yet, is not as broad as what R can bring to the table for you today. Right? So still, if you think about the business use cases, it seems like much of the business use cases are related to the business intelligence and data warehousing, and other applications that involve machine learning or modeling are slowly gaining ground. So I think this is where some of the R functions can really become very helpful to provide additional analytical support behind what comes in Spark already from Apache Spark. And therefore, it's a really complementary system, in my opinion, where you have the compute platform on Spark, and you can utilize all the other packages and functions from R and combine them together to really build very efficient data science processes. So interestingly enough, every year Databricks does a survey of all the Spark users, and in 2015 survey, it turns out the advanced analytics components of Spark have been voted to be the most important Spark feature. So that's really interesting. And the other thing is, I've observed that, in terms of the different language APIs, like I was mentioning, R has only become available since middle of last year. So it's been just about a year or a little bit more than that. So already, towards the end of last year, you saw that 18% of the users in Spark are using R. Scala is still dominant, and so is Python. Python is also very popular, but I believe the R utility is going to gain popularity pretty quickly. So one other thing I'd like to mention that in terms of open source packages for doing statistics and machine learning in R, there are a couple of them right now that one comes from Apache Spark as a part of the Spark distribution, which is Spark R. And I think you can do quite a few things in terms of the ETL data wrangling with Spark R in my experience, but I think the modeling aspect of it is still pretty weak. Alternatively, you can use the Sparkly R ML packages that have become available, and those provide bindings to the Spark ML functions, the Spark ML API and then that enables you to develop machine learning models and so forth, somewhat more than the Spark R. So with that introduction to Spark, I want to take you through what a data science process typically looks like. And your process might be slightly different than what is given here, but I think you'll agree that your data science process will involve a few of these steps, or maybe all of these steps. First off, you'll need to have a very crisp definition of the business problem that you're trying to address with your modeling. And you'll have to plan and prepare for the environments and have the storage system for your data and make sure that the data is ingested properly. And after that, begins sort of the data science part of that process, right? Where you start to explore and understand the data, do visualizations, create model, and see how your model performs. And likely that you have to iterate through that step a few times, in terms of creating and evaluating models. And after you feel that your models are pretty good, then you would have to deploy the models in production. So your workflow can call this model with your new data and get scored outputs. So to address that, we have developed what is called the team data science process. So in this, the web address is given towards the bottom right-hand corner there. So the objective of this is to give you enough information about how you would like to create your environment for a team of data scientists, and then how you would like to go through your process step by step in a fairly systematic manner. We provide you with different templates, access to GitHub and so forth, so you can do source control. So it provides information about an environment that you can replicate for your own needs, with enough information about resource management and all that thing. So I encourage, there's a talk that's later going on this afternoon between 3 and 4. I encourage you to make it if you can do that. I think it's going to be beneficial if you're a data scientist. Now with that, the next couple of slides I'm going to talk about is very simplified data science process and try to do a demo and show you how you could do that using the Microsoft R server on HDInsight clusters. So there are more steps than this, but I think I'm going to only touch on the data preparation part, modeling, model evaluation, and ultimately how you would operationalize that using Azure, different Azure services. Okay. So in this demo, I'm going to cover how you would provision clusters using PowerShell, how you prepare and join different data sets using Spark R, how you would create models including the scalar functions, and how you deploy the models in Azure ML. So this is one example of what a pipeline could look like for you. So you could have your data in Azure Storage or Azure Blob Storage or Data Lake. For the data preparation processing, you could use HDInsight Spark. And for modeling purposes, you could use the Microsoft R server. Once your model is satisfactory, you would like to deploy it, you can use the Azure Machine Learning and create a web service which can talk to your web applications. In addition to that, with the part that I will not show, but you can do this as well. And the previous speaker was speaking to that pretty efficiently, actually. So you can also do dashboarding using Power BI, and you can pull data directly from Blob, or you can register SQL tables in Hive in Spark context, and those Hive tables can also connect directly to Power BI, and you can do dashboarding with that. So the technologies that I'll show, you will use Azure Blob Storage, R Server on HDInsight, Azure ML, including the Azure ML R package that enables you to deploy a model from the R Server on Spark. and Power BI, which I'm not showing as well as an optional situation. Okay, so I showed you earlier that if you're interested in spinning up your own HDInsight clusters, you could do that through the GUI. But if you have a team of data scientists or engineers and you'd like to spin up quite a few of them, I know that the GUI way of doing it might be kind of cumbersome. So one way of doing that or not automating that process could be through PowerShell scripts. One example script is shown here, and this PowerShell script uses what is called Azure commandlets. So for example, it's shown in yellow here, this command called new Azure resource group deployment. That's a commandlet that you can use to manage and create Azure resources. And to go with that commandlet, you will also need what is called an ARM template or Azure Resource Management template. Now that template specifies what kind of resource you would like to create. And so I'd like to click on that and just show you. There's a bit of a lag between what's showing up here and, okay, right, no, sorry. Okay, so the ARM templates look like this. Maybe it's kind of too small to see. All right, so here it's a JSON file that will help you specify a few different things, that it is a Spark cluster. You can specify how many worker nodes that you would like to create the cluster with, the size of your machines, and so forth, R server. So once you specify these things, the script will run and create all the clusters for you. And similarly, once you're done with these clusters, you can simply delete these clusters using similar scripts. So I'll try to see if I can get this going and show you. So as a part of the demo, you can, let's see. Okay. So here I have a script. First, let me show you something else. So I'm here on my Azure portal. You can see that a fair number of clusters have been created already. Now, you can choose a resource group on which you want to build additional clusters, for example, and you can specify all of that in a parameter setting file. And okay, so now I have 4 clusters. I want to create 5 additional clusters. So this is, you can run the entire file, but the entire file has some other things that I don't want to run at this moment. So I can come here on my Windows PowerShell and submit that script. And you'll see 5 clusters are starting to get created right now. And if you come to the Azure portal again, it takes a few seconds for it to show up, but you should be able to see that the additional clusters are starting to get provisioned at this time. So I'll let it go for a few more minutes because it can take a bit of time to show up. So, okay, once you've started that, you will see a few different, the blue circles will indicate that these clusters are spinning right now. They're in the process of getting provisioned, and once they're provisioned, you will see a sort of a solid green circle. That means that the clusters are ready to use. It takes about 20 minutes, but that way you can spin up really lots of clusters you want, but still within a span of 20 minutes. Now, once the clusters are ready, then you can start doing your analytics. For example, I'm going to show the analytical process with the airline data set that has been used very frequently with all kinds of our server tutorials and blogs and so on. So the airline data set consists of on-time flight departure and arrival, and you can integrate that with the weather data and try to build up a model that will utilize your weather information plus information about your carrier, the airline vehicle type, the arrival, departure report, etc., as features, and create a model and tell you whether the flight is going to arrive 15 minutes later or not. Okay, so it's essentially a binary classification problem. So the data can be downloaded from here. So one of them is from the US Department of Transportation. The other one is from the National Oceanographic and Atmospheric Association. So let me jump back to the demo a little bit. And as the demo is running, I'm going to come back and explain some of the slides to you. Okay? All right. So now you can see that all these different 5 clusters are starting to get provisioned. You can also delete the clusters. So I'm going to simply delete the first 4 clusters, and you'll see how easy it is really to spin up teardown cluster for if you want to create a data science platform, how easy it is to sort of create that platform in the first place. And if I go over here, then I'm sure what I'm going to see is so it shows you all these clusters, right? And I started to delete cluster number 1 through 4. So if I click on one of them, I'm sure it's going to say that it's in the process of getting deleted or something like that. Yeah, there you go. So this is how you can create and delete clusters. You can also manage the clusters, install additional software, customize it through easy script actions like I was showing you earlier. So once your cluster is prepared and you have customized it to the extent you want, you can SSH into your cluster. So here you go. So you can SSH in, and you can use RStudio server that's installed on the cluster edge node to start doing some of your computations and data science processing. So the first step usually is to get data from HDFS, which is shown over here. And I'm not going to show you all the steps here because some of the steps do take 1 or 2 minutes to finish. And so as a matter of timing, I can't fit everything in the rest of the time that I have here. But once the data sets are all in the Spark context, then you can cache them in memory. And once you cache them, the rest of the computations will go really fast. So you can do a head on this data set, and you can see how the data set looks like. And this is the airline data set. You can see carrier, airport information, and so forth. And then I'm simply going to do a head and count on the joint data set, which will simply show you that the airline on-time arrival departure data has now been integrated with other information such as visibility, wind speed, and all that kind of thing. All of these are features that later you can use to create a model. Okay, so the modeling part, you can use a formula such as this, where you're trying to fit the arrival departure by 15 minutes to various other features that are in the data set, including month, day of the month, and so forth, and some weather features. You can fit a logistic regression model. Again, that'll take in the order of about 1.5 minutes or something in this cluster that I have with only 2 worker nodes. It's a small cluster that way. So what I'm going to show you then, after the model is created, you can do some evaluation of the model, in terms of how accurate your model is, which factors or which features are more important in your model, that kind of analysis. So you can first of all take a look at the model. The model is really large in part because there are lots and lots of features. If you take into consideration all the arrival, departure, airports, which can be in order of hundreds. So you can evaluate the model and see which factors might play an important role in your prediction. Okay. Then the other thing you might want to do is to take test data sets. So in this case, the test data set has been taken from year 2012, and for training, we had used all the data set from 2008 through 2011. Okay. So it's a forward-looking test data set, and you can use functions such as RX rock curve, RxAUC, etc. to get the accuracy of your model and do plotting. So plotting is shown here, for example. The AUC is not extremely good right now, but I mean, like I was mentioning, you usually have to iterate through this process a few times in order to see which parameters and which models best fit your business scenario. Okay. Now, after you have evaluated your model, you might want to publish that model as a web service, so you might be able to consume it from your other applications. I'm going to come to that, but I want to present one or two slides as introduction before I go to that part. Okay, so these are things that I didn't cover this, but anyway, so you can join data sets using Spark SQL and Spark R, which is something I missed showing in the demo of the code. But these are things that I showed where you can model, create, do predictions with this model using test data set and create some ROC curves out of it and so forth. Okay, so here are a couple of things that are worth mentioning. So in some work that has been done by one of my colleagues, he has shown that the Rx logit function in particular scales fairly linearly in the Spark compute context. So he has taken billions of rows in a fairly large cluster, 100-node cluster, but he has shown that up to 2 terabytes of the data, the modeling is quite linear. Right? So that was a good observation. And like I was mentioning to you earlier, there are some open source packages that are now available for you to do machine learning in the Spark, right? Using Spark's native ML packages, functions. For example, Spark R and Sparkly R. So recently a comparison had been done between these 4, including CRAN R, which essentially ran on the head node of the edge node, and the other ones were able to use all the worker nodes. So it was shown in this preliminary result that the logistic regression from our server scaled pretty linearly, and it performed really well in terms of your the compute time, especially when the data set got fairly large in terms of 200 or 300 or 400 million rows. So we need to work on this quite a bit more and make sure that it applies to multiple data sets and so on. But this is an interesting observation that I thought I would share with you, although it's kind of preliminary at this time. So okay, the point I was coming to is how you would publish web services in Azure Machine Learning. So how many of you have heard about Azure Machine Learning? Can I get a show of hands? Some of you, maybe actually quite a few of you. That's good. So I'll give a brief introduction to Azure Machine Learning, but won't dwell on it then. So it provides you with the capabilities and functions for creating machine learning models really easily in a drag and drop fashion in this environment called Azure Machine Learning Studio. Right? Now, once you have created your model and you're satisfied with it, then you can easily publish it as a web service. And that's also one of the real good benefits of using Azure ML. However, I'll switch back. Okay, no, maybe let's do it here and then go to the demo. You can publish web services in Azure ML directly from the R server that's running on your HDInsight cluster. So that's a very useful functionality, and the Azure ML package that has been written and published in CRAN provides you with the ability to do that. So you have the Azure ML library, you source that library, then there's this function called publish web service. So you create your model and you can simply use this function to publish your model on the web service, and you can also consume it in the same environment. For that, on the left-hand side, what I've shown you need a specification for your Azure Machine Learning Studio in terms of workspace ID, authentication, and all that kind of information. But with this, the machine learning, the model can be operationalized in Azure Machine Learning. Okay, so going back to the demo here, the last part I want to show you in terms of this demo is how you would create a. Okay, so here's a similar code that I was showing you earlier in the slide. Again, if I run this code and call my the web service MS-DSS Ignite and run it, it'll take a few seconds, but it should show up now in the list of web services that I have in my Azure ML. Let's see. Repeat what? Sure. So, okay. So you see that this web service has been published. You can navigate through it a little bit, get the URI, and then utilize that for your other applications. But to answer this gentleman's questions, I'm going to come back to my RStudio environment here. So this part of the code is what is publishing the web service. So you source the Azure ML package. Then here's a tree model that you would like to operationalize. First of all, you'll have to convert the tree model into R using R model, R part. So and then create this functions called the scoring function, which is simply doing a predict using the model and new data, right? Then you have to import the workspace specifications. After you have done that, you provide the workspace information, the scoring function, the name of the web service, and some example data set. With these inputs, the function will create the web service. And later on, when I'm going to talk about some of the resources that we have published, you'll find these codes are also available there. So if you don't absorb everything during the course of the presentation, there are resources that you will be able to get to. Okay. So coming back to the rest of my presentation, I take the final few moments to discuss where you can find the appropriate resources which will enable you to adopt this code and all these functions, etc. So one of the important resources is the following. So we did a tutorial in KDD very recently, and that tutorial has quite a bit of information about how you would provision the cluster and give you access to all the codes that I was showing today. Okay, so here's the public GitHub repository for it, and in particular, the code directory has all the codes that I was showing you earlier. So in addition to that, there are quite a few samples in the Cortana Intelligence Gallery, and they address important business use cases. And you'll also find that they are linked to public GitHub repositories from which you can pick up the code and deploy these resources and solutions pretty easily. So if you go to view code, you will be able to get to the GitHub repository and get the code. And there is also information about how, I'm not finding it here. Oh, I think it's in the GitHub repository, sorry. So in the GitHub repository, you'll have an extensive description of the business use case and the solution, and then you can deploy these resources with the code in Azure, okay? So finally, we also publish blogs, and some of these are mentioned here. And there are some examples of how you would do some scalable analytics in the Hadoop and Spark context, for example. So finally, we'll summarize and acknowledge my colleagues. So our server on Azure HDInsight is a managed distributed computing environment that you can use for your data science. We have shown quite a few examples through yesterday and today, which will help you if you're interested to adopt these processes. And scalable end-to-end data science process can be built on HDI clusters using HDInsight, our server, and some of the other Azure resources that you might need for dashboarding, publishing web services, and so forth. And we have published resources that will help you, I am hoping, to sort of adopt some of these for your own workflows. Although they might not be exactly similar, but I'm hoping that the code, etc., is going to be useful enough that you would be able to adopt and change some of that and use for your business cases. With that, I'd like to thank a few of my colleagues who contributed very significantly to development of the content as well as the presentation. So thank you, and it seems like there are maybe a couple of minutes left for questions, which I would be happy to take.